Okay, so in this session we're looking at the quadratic formula. I think this is the continuation of the stuff that we have discussed in our previous session, particularly finding the value of x using completing the square. It is that methodology that brought us to this quadratic formula: x is equal to negative b plus or minus b squared minus 4ac over 2a. But you would ask, how did we get from here to here? Again, I would like you to go back to the stuff that we discussed in completing the square, and let's try to solve ax squared plus bx plus c is equal to 0. And let's see where it takes us. First, since we can't have any real number other than 1 in our leading term, we're going to do this. We're going to divide both sides, all sides, by a. Okay? So let's rewrite this. This would be x squared plus b over ax plus c over a, and as you can imagine, 0 over a is 0. Okay. Now let's move c over a, meaning what, the last term, to the other side of the equation. So you would have x squared plus b over ax is equal to, probably write it here, minus c over a. So if you move c over a to the other side. Now, let's go back to the methodology of completing the square. In order to complete the square, we have to take half of BA and we have to square it. So what is half of BA? Half of BA is B over 2A. And then if we square it, if we square B over 2a squared, we end up with b squared over 4a squared. Okay? Half of ba squared will give us the last term. So I'm going to rewrite this again. X squared plus b over ax. Now our last term, which is b squared over 4a squared. Now, since this is a new item, then we have to add it to minus c over a. So this will be b squared over 4a squared minus c over a. Okay? Now we need to translate this. How did we get this? We got this by finding half of ba and squaring it. So this means what? X plus b over, which is half of b over a, which is 2a, squared is equal to b squared over 4a squared minus c over a. So we end up with this equation. Okay? Now, let me rewrite that. So if we have x plus b over 2a squared is equal to b squared over 4a squared minus c over a. Now let's find the common denominator between 4a squared and a. Between 4a squared and a, the common denominator, the least common denominator, is 4a squared. So I need to multiply this by 4a in order to make the denominator the same. So let's see what our new equation looks like. Over 2a squared is b squared. So if you multiply 4a by c, you're going to get minus 4ac, and the bottom becomes 4a squared. Okay? Now, if this is equal to this, then the square root of this, which is x plus b over 2a, is equal to plus or minus the square root of b squared minus 4ac over 4a squared, right? Now, look at this. You can find the square root of 4, which is 2. The square root of a squared is a. So you can take the denominator out of the radical and simply write 2a. your final answer. We are actually reaching to solve the equation. So x is equal to move b over 2a, so this is minus b over 2a plus or minus the square root of b squared minus 4ac over 2a, right? Then x is, since you have the same denominator, we have found the solution of our quadratic equation, which is negative b plus or minus b squared minus 4ac over 2. And this is the formula that we use. Okay? So the exercise of this is, it tells you how important completing the square is in solving quadratic equations. Okay? So now we know our quadratic formula and where its origin is. It makes our life easier to solve any quadratic equation as long as we use this formula. So I'm going to give you 3 examples, distinct examples that you can use, which is quite simple. Suppose you have 2x squared minus 6x plus 1 is equal to 0. So solve for x. All you need to do is to know which one is your a, which one is our b, which one is our c, right? So this is your a, this is your b, and this is your c. Okay. And plug into the formula. X. Now make sure, probably let's write it here. A is equal to 2, b is equal to negative 6, and c is equal to 1. Okay. So if b is negative 6, negative b would be positive 6. Plus or minus, then square b minus 4 times a is what? 2, and c is 1 over 2 times 2. Okay. So this is not a difficult, but it's just only plugging in. So you have negative 6 squared will give you positive 36. 4 times 2 is 8, so 36 minus 8 over 4, right? And this would give us 6 plus or minus the square root of 36 minus 8 is 28 over 4, right? Now, let's look at the square root of 28. The square root of 28 is the square root of 7 times the square root of 4. Is that right? Then this would give us 6 plus or minus the square root of 4 is 2 to the square root of 7 over 4. And probably at this juncture what you need to do is, I mean, you have found the solution, but you can also go ahead and simplify. Find the common factor between 6 and 2, it is 2. Then it becomes 3 plus or minus the square root of 7 over 4. And if you can simplify 2 and 4, so you would end up, probably let me write it here, your final answer would be 3 plus or minus the square root of 7 over 2. Okay? So I know, I'm sure that plugging in is not going to give you any hard time in solving the quadratic formula. Okay, so let me do another one. 8x squared plus 2x minus 1 is equal to 0. You know x is equal to minus b plus or minus. I always use the formula on hand just to make sure, you know, that I will not be wrong in plugging. So your a is 8 in this instance, your b is 2, and your c is negative 1. So you go ahead and plug in. So your negative b would be negative 2 plus or minus, and this would be 2 squared minus 4 times 8 times negative 1 over 2a would give us 16. So this would take us to negative 2 plus or minus, this would be 4. Negative 4 times 8 is negative 32, but negative 32 times negative 1 is plus 32 over 16. Then you're going to go ahead, negative 2 plus or minus 36 over 16. And mind you, the plus and minus tells me what? There are two solutions in any quadratic equation. So this would be negative 2 plus or minus 6 over 16. We might as well rewrite this. This means what? One of them is negative 2 plus 6 over 16, and the other one is minus 2 minus 6 over 16. One of them is plus, the other one is minus. Then negative 2 plus 6 gives us 4, and 4 over 16. So this one takes me to 1 over 4, one of the answers. If you do this, negative 2 minus 6 is negative 8. Negative 8 over 16 gives you negative half. So you end up. In our previous exercise, we ended up with an irrational expression, and in this one, we ended up with rational expression. Okay? Okay. Let me do another one. So, we have now 3x squared minus 2x plus 4 is equal to 0. Okay, and let's solve this. Now, your a is 3, your b is negative 2, and your c is 4. Now let's plug in. If b is negative 2, so your negative b would be 2 plus or minus, and this would be negative 2 squared minus 4. Your a is 3, and then your c is 4 over 6. Let's go ahead and simplify this. So you end up negative 2 squared is 4, right? And 4 times 3 is 12, and 12 times 4 is 48, but it is minus 48. Okay. Over 6. Let's go ahead and simplify this. So 2 plus or minus, this becomes minus 44, the square root of minus 44 over 6. So you know now the solutions that you get are not real numbers but complex numbers, right? Okay, so let's go ahead. Let's simplify the square root of negative 44. So as you know, the square root of negative 44 is the same as saying the square root of negative 1 times the square root of 44. Right? And the square root of negative 1 is I. And we can take a perfect square out of the square root of 44. You can say the square root of 4 times the square root of 11. So you would end up, this one is I, this one is 2, the square root of 11. So we might as well make it much more understandable to 2i to the square root of 11, right? So what this would give us, from here, what we're going to do would be, we will write 2 plus or minus 2i to the square root of 11 over 6. We're almost done. I mean, in fact, we are done, but just let's simplify this. Now we have factors of 2. Take 2 out. Then you have 1 plus or minus I to the square root of 11 over 6. Then go ahead and simplify this. If you simplify this, then your answer will be I to the square root of 11 over 3, and then we are done. So we have used the quadratic formula for complex numbers, for rational numbers, and for irrational numbers. And that's why we call, in factorization, particularly in factorizing trinomials, the quadratic formula is always the 911. If you have a hard time doing simple factorization, you use the quadratic formula and you reach it, okay? So that ends our session.